Okay, here we'll be talking about a moment about an axis. In this case, I have an axis that's defined by 2 points, A and B, and it goes from A to B. So it has a direction associated with it. And we have a point out in space where a force is applied. And again, it will be an R vector from this point A is how we'll define it. From this point A to the point capital R. And that's where this force is applied. And what we want is this moment about this axis. And we might want to do that to actually find the amount of torque applied to a bolt through a ratchet wrench or some other type of wrench. The moment generated by your force is not aligned with the axis of the bolt. So the calculations we have here is we need a unit vector that's pointed from A to B, and we'll call that lambda AB. And in this case, these are the computations. And I will let this rotate so that you can see it a little bit. See where things are in this case. And if you do your right-hand rule, you can see, yes, MAB is kind of pointed in that direction. So, let's see, R cross F dot lambda AB. That's how we calculate the magnitude of this vector. But here you see it's negative. This MAB is a scalar value, so it can be negative. And to get the actual vector, though, we then again multiply it by the same lambda AB to actually get the moment on the axis AB. So this now is the vector, the orange vector shown in the view. Okay, to see this, or what's really happening is we've got 2 steps. So we're calculating our R cross F, and then we're projecting that onto the axis. So here we can see that, again, the magnitude of AB is now R cross F, cosine of this angle alpha. And R cross F is shown here for these particular vectors. If we go back here to our original vector, and one of the things we can do is we can pick a different point along this line. So if we pick a different point along this line, we see that the MAB scalar and our vector MAB don't change. So we can pick any point along this line. I challenge you to show that algebraically.